All right, so this is the second to last live stream. Any questions you have would be good to email me between now and tomorrow because Wednesday is the last live stream. Thursday, start of the exam. You have at 12:01 a.m. The exam opens up. You have until Wednesday next week, December 16th, at 5 p.m. to complete the exam, not start the exam. If you try to start the exam at 5 o'clock, you will find the system locked you out. Now, 5 o'clock is a hard deadline. You don't get any extensions beyond 5 o'clock unless you have an incomplete in the course. And the school is pretty rigorous about not letting students take incompletes unless there's things outside your control. We mean outside your control, like military deployment, massive hospitalization. So go ahead, get that exam out of the way. I created this wide window for you because I have a feeling a lot of instructors are scheduling their exams for Friday and Monday. This gives you the flexibility to complete your exam when you want to. That said, about Tuesday of next week is when I'm going to kind of stop entertaining grade change requests or hearing you out if you say, well, I want, I think I'm only like a couple points away from this grade. Can I have it? Simply because by Wednesday at 5 o'clock, I need to submit my grades. They're due actually Thursday by noon, but what we have to do is submit them Wednesday night and then check back Thursday to make sure that the grades have actually gone through. So the sooner you take your exam, the sooner, if you want to contend your grade, you have the option of contending your grade. Now, that said, when it comes to contending your grade, one thing I'm going to check to see is if you did all the homework, if you did all the discussion boards, if you did all the assignments this semester. If you haven't done them, I'm less inclined to give them to you. Also, when we talk about grade change contending, meaning like, well, can I get a bump up? 1 point within the grade you're looking for is usually a reasonable point to request that. If you're like 2 or 3 points away, you're definitely going to get turned down for a grade change request. So again, get those out of the way earlier. The earlier you deal with them, the earlier we can talk about it. Definitely Wednesday, the day the exam is due, I'm not going to really be responding to emails regarding that. I still actually kind of need to set up for the spring. We hit the ground running December 7th. So the courses need to be set up basically between now and Christmas. So I'm here to answer any questions you got. I see there's 3 concurrent viewers, so if you got any questions, feel free to ask in the chat. Otherwise, I'm just going to kind of just be here. Did you review number 37, number 30 on that work? All right, just 1 minute. Otherwise, it's going to really annoy me if my fingernails are all the same length. All right, 37, 38 on the homework. And then we'll get to the discussion board topic next. So 37, draw the stepwise mechanism for the following reaction. So when we get bromine addition, most common mistake I see on this is actually not drawing the arrow back. So you can have the one arrow attack the bromine. We're going to break this bromine-bromine bond, and this is going to give us bromide on the other side. And then actually we have to draw an arrow back to the other carbon. And the idea here being is that bromine has lone pairs on it, and one of these bromine lone pairs is going to form a bond back to the carbon to give us this, I'm going to draw it crudely here, this bromide, this kind of like bromine, bromine cation intermediate. So that'll be the first step, and then this bromide, we get attack, that kicks the lone pairs back up, and we end up getting this compound here. So what I can do is I can kick it over to the desktop for you. Save and exit. Oh, huh. Guess I should also do the mechanism too, shouldn't I? So for the mechanism, so the bond, we're going to draw it from the bond to the bromine, from the bromine back to the carbon. We're also going to break this bromine-bromine bond. So you've got the mechanism, the double bond forms a bond with the bromine. That bromine subsequently forms a bond with one of the carbons. We break the bromine-bromine bond. And that's your answer. For the next one, 38. Go back to the camera. Pretty much the same thing for the double halogenation. You go through the first step with a chlorine. So instead of bromine, it ends up being chlorine. You get the Cl and the Cl, and then it's just the same mechanism before. Cl, Cl. Attack from the double bond, attack by the lone pair, break the bond, and it's just pretty much where the bromine was. You're going to put chlorines in its place. Now for the discussion board, this is the making and naming of ethers. So ether synthesis is really problematic, especially if you're ending up with I did the bromine and chlorine cycle arrows from the top, but it told me it was wrong on both questions. Most likely it's just a matter of where you're drawing it from. So it's going to be particular when you want to draw So when you draw the first bond, you need to have your cursor over this bond so it gives you a big box. You don't want to draw, if you have the box here to the carbon, it's going to think you're trying to draw a bond from the carbon to the bromine. So you got to make sure you're highlighting the box that contains the triple bonds and that you're drawing it to the box around the bromine. And the same thing is going to be true for the other arrow. Make sure you start out with the cursor where you have a box over the bromine, and then you're actually going to draw it to the box over the carbon, so just to the right. And then for breaking this bond, it'll be hard to see, but there's a box between the two bromines. So you make sure your box starts here and finishes up on this bromine. But that would be my guess, is that it's just being really nitpicky about where you're drawing from. And the honest answer is there's not a lot of good software on how to do this. But yeah, when you're drawing this, make sure that your starting box is within the triple bond and the finishing box for the bromine is actually to the right of this triple bond. If you go slightly over and grab this box by accident, it'll count that wrong, even though it's easy to see it here. But even on my end, if you draw an arrow from this box or this box, it effectively looks like the arrow is coming from between the two. All right, ether synthesis. So when it comes to ether synthesis, these are really not easy to synthesize if you're going through what's called an asymmetric ether. So here we got ethanol. And propanol. And when we form an ether, it's an oxygen with the carbon chains on opposite sides. So we've got one, so let's call this R1, R2. So if we have a reaction with R1 and R1, we're going to end up getting the diethyl ether. So this is R1, R1. We can also have this reacting with this to give us the ethyl isopropyl ether. So R1, R2. Now you could also say, well, we could flip it around to have the R2 on the left, the R1 on the right. It doesn't matter by symmetry, they're the same thing. And then we can have the second alcohol reacting by itself to give us the dipropyl ether. So R2, R2. So you actually end up with 3 unique combinations of ethers you would get out with this, and to separate them out, you would need to do you most likely would just do a distillation, and that distillation you would pull off the different ethers. Now, when it comes to the ethers, I prefer the functional naming, not the, what's the other one called? Yeah, there's one where it's like you call it a methoxide. It's not widely used. It shows up esoterically in Chem2, but for other reasons. But typically when we name ethers, because ethers suffer from 2 things. 1, they're horribly unreactive. And 2, they're generally only used as solvents. Because they're so unreactive, they're typically not used for much. So when you see ethers named, mostly you're going to see this dipropyl or diethyl ether or this ethyl propyl ether. So naming them as groups branching off of the oxygen. The reason being is that it's just easier to do. Now you could also do the ethyl propoxide, where you treat this group as an alkoxide. That's definitely a naming scheme. It's just not one I advocate, because you don't see this propoxide naming scheme for ethers show up unless you have a very complicated molecule. And then it's typically the ether is treated as a functional group hanging off of a bigger chain. So practically for ethers, this alkyl naming scheme works just fine. It also has a lot more utility because you can actually name the chains. So if you have branches coming off of the chains, let's say you have a methyl group here, you would just name it as 2-methyl propyl. That would be the branch coming off of it. Fun fact, for the fall of 21, we're looking to switch so y'all did the practical last week. We're looking to switch the practical from the ester. The ester was actually meant for 252, and we didn't like the practical that was currently being given for organics, so we just kind of adapted it for the practical for Orgo 1. It'll also be the practical for Orgo 1 in the spring as well. But we're going to switch to forming di-N-butyl ether in the spring. So basically, what you did, but instead of having the phenol and the acetic anhydride, they're just going to load in butyl ether. All right, see you next semester, Lauren. Any other questions out there? But be right back. All right, let's go ahead and close out this live stream. There is one live stream left this week. This is Wednesday from our normal 10 to 11 time. After that, available by emails during final weeks. And many of you I will actually be seeing again next semester. So good luck on your exams, and I will see some of you after the break.